3I Atlas. The most intriguing cosmic visitor we've ever had is leaving the solar system. This comet has been entertaining us for a little under a year now, and in that time we've seen a flood of new research, hundreds of papers published, speculations over it being an alien invader squashed, and observed the building blocks of a distant planetary system up close for the first time. Surely one interstellar interloper can't give us more than that. Well, it turns out it can. As 3I Atlas rounded the Sun, it exploded to reveal its inner secrets. 3I is now on its way out, past Jupiter's orbit, and slipping beyond the limits of our instruments. And once it's gone for good. So this is it. It's time to take stock of the spectacular science of this final stretch of 3I Atlas's journey through the solar system. I'm Alex McColgan and you're watching Astrum. Join me today as we head back to 3I Atlas for one last time to dissect the groundbreaking research that has emerged since it passed Earth last December. From the discovery of even more jets to a rare cosmic alignment, and explore the final course-altering encounter that awaited this weary traveller at the edge of Jupiter's influence. As I'm sure you already know, we've been charting 3I Atlas's course from the moment it was first spotted. I've already made 3 videos on it myself, and you can watch the latest one here. There have been hundreds of observations, papers, and discoveries made while 3I Atlas passed through our neighbourhood, but the last few months have definitely been the most dramatic. In late December 2025, as 3I Atlas drifted towards its perigee, or the closest point to Earth, it did not forget to bring some Christmas gifts with it. At a distance of 1.8 astronomical units, nearly 270 million kilometers from us, 3I Atlas put on an explosive show. Observations from NASA's Sphere X mission captured the comet full-on erupting. Usually, water ice remains stable in the deep cold of space, but once this comet got closer to the Sun, its ice started sublimating, turning from solid straight into gas in massive quantities. And the trigger for this explosion had been building for months. To understand what was going on, we need to look beneath the surface. Comets are roughly 1/3 water ice, much of which is buried deep in their cores, shielded from the harsh, energetic radiation of the Sun. Even after 3I Atlas crossed its perihelion in October, that heat hadn't yet penetrated deep enough to warm the interior. Think of it like a baked Alaska. The meringue on the outside was insulating the frozen ice cream middle. It wasn't until nearly 2 months later that the Sun's immense energy finally reached the comet's icy interior, and it began to vaporize violently, erupting from 3I Atlas in huge jets. And within those jets was more than just water. Methane, methanol, ethane, formaldehyde, these were the chemical fingerprints of the ancient star system where it formed. It appears that 3I Atlas had packed an entire hydrocarbon lab for its interstellar journey. The result was a dramatic surge in activity, with water emissions showing a tremendous 40-fold increase. And this massive halo of gas did more than just make the comet brighter. It offered a vast, dense target for fast-moving particles from the Sun to slam into, creating the perfect conditions for a phenomenon that scientists had long been looking for, but that had so far eluded all attempts at detection. You see, comets that originate in our solar system usually have a telltale X-ray signature. As the sublimated gases in their coma interact with the solar wind, a process called charge exchange reaction occurs, emitting characteristic X-rays that we can detect on Earth. However, every single attempt to detect X-rays coming from Oumuamua and 2I Borisov, the 2 interstellar objects that preceded this one, ended without any positive results. Would 3I Atlas be any different? Well, as we have seen countless times so far, this particular object is quite fond of surprising us, and it did not disappoint this time either. Images taken by JAXA's XRISM satellite in late November 2025 revealed a faint X-ray emission signature around the comet nucleus, marking the first time we have ever detected these wavelengths from an interstellar visitor. The data suggests 3I Atlas could be surrounded by a diffuse cloud of gas, extending up to 400,000 kilometers from its nucleus. For context, that is larger than the average distance between the Earth and the Moon, and wide enough to fit every planet in our solar system side by side. And this discovery goes further than just a simple first detection. It shows that even interstellar comets interact with the solar wind in much the same way as those in our own system. And in doing so, it gives us a rare, brand new way to probe any future visitors. It's amazing how much can be learned about the universe just by peering up at it with the right equipment. There's so much grandeur out there, swirling galaxies, exploding stars, and breathtaking nebula. But these sites aren't just for space agencies who have their own Prism or Hubble. You can get started from your own garden, thanks to the sponsor of today's video, Dwarf Lab and the Dwarf Mini. The Dwarf Mini is a compact telescope about the size of a paperback book, but one that boasts some really impressive user-friendly features. I found it really simple to set up. Once I'd attached it to a tripod, its app let me tell it what I wanted to see, say the Andromeda Galaxy. The Dwarf Mini then automatically pointed to Andromeda, using the stars to orient itself. The Dwarf Mini's live stacking feature captures multiple images over time and combines the collected light into a clearer final image right in the app. No computer port processing needed for a first result. So if you're a space enthusiast or are buying a gift for one, start exploring the universe yourself by scanning my QR code or clicking the link in the description below. For a limited time, if you buy the Dwarf Mini and a tripod, they'll even add their Dwarf Mini backpack to the bundle for free. Give it a try. Now, back to learning about 3I Atlas. If a giant X-ray aura wasn't enough, 3I Atlas's heartbeat also underwent a dramatic shift after perihelion. Comets have an intrinsic spin, a rotation that can be measured by watching how their brightness fluctuates over time. Because 3I Atlas has multiple jets fanning out into space, its rotation can cause almost a 30% variation in its brightness as seen from Earth. This creates a rhythmic pulsing, a lighthouse effect that repeats every few hours, almost like a long, drawn-out heartbeat. Before perihelion, 3I Atlas had a rotational period of 16.2 hours, but after passing the Sun, something changed. New measurements from December 2025 revealed that its rotation had sped up. Its period was now just 7.1 hours, meaning 3I Atlas was spinning more than twice as fast. This spin-up was likely a direct consequence of its orbit around our Sun. As 3I Atlas approached our star, the intense heat triggered even more outgassing and activated new jets. These jets applied enough torque or rotational force to the nucleus to wind it up, much like how astronauts use thrusters in their spacesuits to guide their movements. Soon after this boost, as our traveler continued its journey, it headed straight towards another giant of the solar system and passed us along the way. Ever since we first spotted this interloper, astronomers worldwide have been trying to figure out exactly how big its nucleus is, and early estimates were a bit all over the place. Figures for its diameter in those first few months ranged from as small as 320 meters to as large as 5.6 kilometers. But shortly after we rang in the new year, an exceptional alignment finally put this mystery to rest. At any point in Earth's orbit, you can draw an imaginary line from the center of our planet to the center of the Sun. This is the Earth-Sun axis. On the 22nd of January 2026, 3I Atlas came within an incredibly narrow 0.69 degrees of this line. This alignment was an unprecedented opportunity. Now, because the Sun was directly behind us, there were no shadows cast by 3I Atlas's dust particles. Usually these shadows would reduce its brightness, but in their absence, the comet was lit head on. On top of that, the light waves reflecting off that dust combined in what is called constructive interference, leading to a massive 20% increase in brightness. This spike in brightness finally allowed scientists to isolate the nucleus from the glowing shroud around it. The Hubble Space Telescope, which had previously observed the comet back in August 2025, took another crack at estimating its size, and this time it was successful. We now know that 3I Atlas's nucleus has a radius of 1.3 kilometers, which is roughly half of the previous upper estimates. And not just that, the opposition also gave us the perfect opportunity to map out 3I Atlas's surface features. By using special filters to remove the symmetric glow of the coma, scientists isolated 4 distinct jets shooting out from the core. The most prominent was the sunward jet we had seen before, except now it was also pointing directly at us. This was joined by 3 smaller mini-jets. Curiously, these were positioned almost exactly 120 degrees apart, and that symmetry raised eyebrows. To some, it looked almost too precise, fueling even more speculation that this might be something more than a natural object. But in reality, such patterns can emerge from the rotation and internal structure of the comet itself. Even so, the idea of alien origins once again captured attention, and coincidentally, instruments designed to search for life elsewhere were already observing the comet. "3I Atlas wasn't just teaching us about different star systems. It was also letting us test our technological limits through opportunistic observations. These were unplanned, unexpected opportunities to observe the comet using spacecrafts and probes already scattered across our solar system. Right when we were blocked out from Earth-based observations, these robotic helpers came to the rescue. As I discussed in my last video about the comet, missions such as NASA's SOHO, ESA's Mars Express, and even the Perseverance rover caught crucial glimpses of the comet right when Earth was blinded. And they weren't the only ones. Even missions still on their way to their targets, deep in their cruising phase, were commanded to wake up and turn their sights towards this visitor. One such mission was the Europa Clipper, on its way to uncover the secrets of Europa's hidden oceans. On the 6th of November 2025, the probe was tasked with 8 hours of continuous imaging of 3I Atlas. The spacecraft, on its billion-kilometer journey, was paused, reprogrammed, and redirected, all to study a visitor no one had known was coming. And the Europa Clipper did not disappoint. It beamed back this UV image of the comet, taken when the spacecraft was about 1 astronomical unit from 3I Atlas. While this might not look like much to an untrained eye, to a scientist, it is a spectrographic treasure. This image was one of the very first direct confirmations that comets from other planetary systems contain the same volatiles that we expect to see in ours. It detected faint dust structures in 3I Atlas's tail and confirmed the presence of hydrogen and oxygen, the telltale signatures of water-ice sublimation. And Europa Clipper wasn't alone. ESA's Jupiter Icy Moons Explorer, or JUICE, the mission bound for Jupiter's moons, beamed back its own images, taken on the very same day, on the 6th of November. As you can see from how bright 3I Atlas looks here, JUICE was a lot closer. From a distance of 66 million kilometers, it took 120 images of 3I Atlas using 5 of its instruments. Now, you might wonder why we're only just discussing and analyzing these images that were taken in November last year. Well, due to its orientation, JUICE is currently using its massive main antenna as a heat shield, meaning it had to rely on a much smaller secondary antenna to send this data home, leading to a painfully slow transmission rate. The full extent of what JUICE observed in November 2025 only made it back to Earth by February 2026. The data, however, was worth the wait. Look at this video, made from 53 images of 3I Atlas cruising through space. This was taken by JUICE's NavCam or navigation camera, As the name suggests, this camera is more of a guide for the spacecraft, meant to snap images of Jupiter's moons only to be processed on board and used to update the trajectory. It was never really meant for complex space science, let alone observing interstellar comets, so this really is a case of right place, right time. In another navcam image, we clearly see the glowing coma of gas around 3I Atlas. The plasma tail, a long projection of charged, fast particles, can also be seen stretching out from the comet, and so can its dust tail. And if these two Jupiter explorers weren't enough, more missions like NASA's Parker Solar Probe and the Transiting Exoplanet Survey Satellite, or TESS, also joined the effort. The Parker probe, speeding away from the Sun during its 25th solar flyby, captured 10 images of 3I Atlas every day for 18 consecutive days, giving us these incredible videos of the comet. But if you felt a bit dizzy trying to spot the comet in these shots, don't worry, TESS has you covered. This wasn't the first time TESS had seen 3I Atlas. Back in May 2025, it had unknowingly observed the comet 3 months before its official discovery. But this time, it knew exactly what it was looking for. Using 28 hours of test data from mid-January, MIT's Daniel Muthukrishna compiled a series of images into a video that showed 3I Atlas as a bright dot with a tail, moving steadily against a backdrop of distant stars. Together, these observations represent something rare, a moment where the entire space community came together. NASA, ESA, JAXA, ISRO, multiple agencies, multiple instruments, all focused on a single visitor, each mission contributing its own piece to the puzzle. And together, they have revealed how an interstellar comet like 3I Atlas behaves. But to understand what it is, we have to ask a different question. Where did it come from? This is where things get a bit more complex. We can't really reconstruct the comet's travel history more than a few million years into the past, so we have to resort to what we can see, the physical and chemical features, to make educated guesses about 3I Atlas's home and age. Back in August 2025, one of the first estimates of 3I Atlas's age came from something called the age-velocity dispersion relation. Essentially, the relationship says that the older objects in the Milky Way are, the faster they travel through space. 3I Atlas was clocked at more than 200,000 kilometers per hour, nearly twice as fast as the Earth is moving, and 2.2 times Oumuamua's velocity. This meant that 3I Atlas was ancient. A study led by Astor Taylor from the University of Michigan estimated its age to be between 3 and 11 billion years old, but a more recent analysis led by NASA's Martin Cordner and based on the comet's carbon isotopes pushed that estimate even further, between 10 and 12 billion years old. That is just 1.8 billion years after the Big Bang. It is entirely possible that the star that birthed this comet is already dead. So we have somewhat of a range of how old this comet could be. But where in our galaxy did it come from? And what kind of star did it orbit? Back in August 2025, Matthew Hopkins and his team wanted to answer exactly these questions. They used Gaia's catalogue of nearly 2 billion stars and reconstructed trajectory of 3I Atlas to project a radiant into the galaxy, essentially the path that the comet took to get to our solar system. Their results suggest that 3I Atlas came from the region of the galaxy called the thick disk. First identified in 1982, the thick disk of the Milky Way is an overdensity of stars that are spread far above and below the galaxy's main plane, a region much more extended than the thin disk or the flatter region where most stars, including our Sun, reside. The stars in the thick disk are some of the oldest in the galaxy. Almost all of them are more than 10 billion years old, with low metallicities similar to those we see in older population stars. And because they have low metallicities, Hopkins expected to see a higher water content in 3I Atlas, and predicted a massive outpouring of water as the comet got closer to the Sun, which we now know was right. 3i Atlas was spewing water like an open fire hose at a rate of 40 kilograms per second, and hidden within this was a crucial clue. A paper released in March 2026 investigated the deuterium enrichment of the water released by 3i Atlas. Deuterium is a heavier isotope of hydrogen, and studying the deuterium to hydrogen ratio of an object acts as a fingerprint of where an object was born. 3i Atlas's deuterium to hydrogen ratio was more than 40 times higher than what we find in Earth's oceans, and more than 30 times what we'd expect to see in solar system comets. This is highly unusual. Such high levels of deuterium are typically seen in only the coldest regions of the Milky Way, suggesting that 3i Atlas was likely formed in the frozen outer fringes of whatever star it was orbiting, which would also make it more prone to being kicked out of said star's system. But what did 3i Atlas actually do for those billions of years since it left its home star system? If we could, hypothetically, trace its trajectory back billions of years, what could we expect to see? Surely, in that time, given the trillions of stars in our galaxy, 3i Atlas would have flown by another star. After all, our Sun can't be the very first star 3i Atlas has ventured so close to. In September 2025, scientists tried to find a definitive answer to this question, looking for, in their words, the witnesses to 3i Atlas's voyage. They integrated its orbit back in time for 10 million years, and using Gaia's catalogue, tried to find out if it had indeed encountered any odd stars on its journey. And the answer is yes, but not in the way you might expect. They identified 62 significant encounters, all where 3i Atlas had passed within 2 parsecs or 6.5 light years of a star. Remarkably, none of these interactions were strong enough to meaningfully change its path. The strongest of these was a K-type star, 70% the mass of our Sun, and even that produced a change of just 50 centimeters per second in the comet's velocity. So 3i Atlas is largely untouched. Our Sun might be the first star it has encountered this closely, the first star to truly alter its orbit. And our Sun wasn't the only local object to give it a tug. On the 16th of March 2026, 3i Atlas passed within roughly 0.35 astronomical units, or 53.6 million kilometers, of Jupiter. That might sound like a comfortable margin on human scales, but in celestial terms, this was a near miss. The distance placed 3i Atlas incredibly close to Jupiter's Hill sphere, the region of space where the planet's gravitational pull is stronger than the Sun's. As the comet swept by, Jupiter's immense gravity gently tugged at its trajectory, not enough to capture it or tear it apart, but just enough to alter its course. Early orbital reconstruction suggested a deflection on the order of a few meters per second. That might seem insignificant, but out here in the slow ballet of the Milky Way, even the slightest nudge can reshape a journey that spans billions of years. This was, in all likelihood, the single most significant planetary interaction 3i Atlas has ever experienced since it was first ejected from its home system. Researchers are still combing through the data. In the coming months, we can expect a wave of detailed studies reconstructing this encounter in full and telling us exactly what happened to this interstellar comet at the very edge of Jupiter's domain. At the time of writing, this object has had nearly 500 papers and studies dedicated to it, thousands of articles, millions of eyes hooked onto news channels waiting to find out more about a rare visitor from deep space. But here's the kicker. Astronomers now estimate that these visitors might not be rare at all. In fact, calculations suggest that there are likely hundreds of them passing through our solar system at any given moment. We simply don't have the eyes to see them. With our detection technology finally catching up, the data suggests we should be spotting a new interstellar visitor every 1 or 2 years. It might not be long before I'm back here talking to you about 4i. To the unwitting eye, 3i Atlas might just seem like another space rock, and they wouldn't be wrong, but 3i Atlas is also a relic of a distant world, a fragment that formed in a giant, swirling, protoplanetary disk of a star likely trillions and trillions of kilometers away. It is a fragment that was ousted from its home way before anything around us, including our own star, had even begun to exist. And for a brief moment, it held the attention of an entire planet as it rushed past us like a cosmic bullet. 3i Atlas is heading back into the dark now, but the story it told us may only just be the beginning. Patreon members got access to this video ad-free, and more importantly, they keep Astrum grounded in a community passionate about space, not just YouTube AdSense and algorithms. So sign up with the link in the description. Being a member means you're part of the reason Astrum can focus on the kinds of videos people actually want to watch. It's where our most engaged viewers are, people who care about learning, exploring, and seeing what's out there. If that sounds like you, join the Astrum Patreon today and be part of where we're headed.